Chapter 6 will be all about similarity. We'll start this chapter with section 6.1 and talk about similar polygons. This will just be an overview of how to talk about and how to find similar polygons. So to start, two polygons are similar if corresponding angles are congruent and corresponding sides are proportional. So again, the angles are congruent, but the sides are proportional. The symbol for similar is just a little squiggly line like that. It's kind of like the line on top of a congruent symbol. And if two polygons are similar, then the ratio, which we're going to write as a fraction, because as you may remember, there are three different ways to write a ratio, and one of them is as a fraction. So again, if two polygons are similar, then the ratio as a fraction of the lengths of the two corresponding sides is called the scale factor. And again, you find that scale factor by finding the ratio of the lengths of two corresponding sides of similar polygons. Let's look at our first example, number 1. In the diagram, triangle ABC is similar to triangle DEF. So part A says, list all pairs of congruent angles. Because remember, if the polygons are similar, all of the angles are the same, but the sides are proportional. So the congruent angles would be, angle A would be congruent to angle D. And again, I just got this from the similarity statement. Angle A congruent to angle D. Angle B congruent to angle E. And angle C congruent to angle F. Part B says find the scale factor. I can find the scale factor by writing the ratio of a pair of corresponding sides. So again, looking at our similarity statement here, I see that side AB would be similar to side DE. So the scale factor would be to take those two side lengths, 25 and 35, and write them as a fraction. So 25 over 35, and we always want to write it as a fraction in lowest terms. So the biggest number that goes into 25 that also goes into 35 is 5. So 25 divided by 5 is 5, and 35 divided by 5 is 7. So the scale factor for this similar triangles would be 5 over 7. I would get the same ratio or scale factor if I took 20 over 28 or 30 over 42. I would get the 5 over 7. And here's just a side note. A statement of proportionality. So if you ever see that while you're doing your homework, what it means is where you're going to take each corresponding side and write it as a fraction. So AB correspond to DE, so we put AB over DE. BC would correspond to EF, so they put those on top of each other, and AC would correspond to DF. So just like that. So again, a statement of proportionality is where you take the corresponding side lengths, write them as fractions, and set them all equal to each other, because we know that if we are told that the polygons are similar, then the ratio of all of the corresponding sides would be the same. So we know that all three would be the same. Let's look at example number 2. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. In order for the polygons to be similar, all of the ratios of corresponding sides would have to be the same. So I'd have to find the scale factor for all 4 pairs of corresponding sides. So if you look here, we see that all of these angles are congruent. So we're going to look at all the corresponding sides. So RU would correspond to DG. So let's put 12 over 8 and put it in lowest terms. So that would be 3 over 2. So all of the other sides would have to have a scale factor of 3 over 2 in order for these two quadrilaterals to be similar. So let's look at RS and DE. So 30 over 20, which we just cancel those, that'd be 3 over 2. So far so good. Next, let's look at ST and EF. 27 over 18. Since 9 is the biggest number that goes into both of those, that would be, again, 3 over 2. So again, so far so good. And finally, UT would correspond to GF. So we would take 33, put it over 22. 11 goes into both of those. So if I divide by 11, I get 3 over 2. Since I got 3 over 2 for each of the pairs of corresponding sides scale factors, I can now state that yes, the two quadrilaterals are similar. And the second part of the question was, if they are, write a similarity statement and find the scale factor. So when I write my similarity statement, I just need to be careful that I write them in corresponding order. So R corresponds to D, S corresponds to E, so on and so forth. So my similarity statement would be RSTU would be similar to DEFG, and then the scale factor would just be that 3/2 that we got as we were checking to see if the polygons were similar. And now on to example number 3. In the diagram, triangle ABC is similar to triangle GHJ. Find the value of x. So since we are told that the two triangles are similar, I know that the angles are congruent, but the sides are proportional. So I'm actually going to set up a proportion for this problem. To do this, I need to make sure I am lining up corresponding sides. So 12 would correspond to 8, and the x would correspond to the 16. So my proportion would be 12/8 equals x over 16. So notice that the 12 is across from the x because they came from the same triangle, and the 8 is across from the 16 because they came from the same triangle. To solve a proportion, you have to cross multiply. So I would take 8 times x and 12 times 16, so I'd get 8x equals 192. After dividing both sides by 8, I would get x equals 24, so therefore my answer for the side x would be 24. And now we come to the first theorem from this chapter, theorem 6.1, perimeters of similar polygons. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So basically what this is saying is if you know what the scale factor is according to the sides of the similar polygons, that same scale factor applies to the perimeters. And now let's apply that theorem. Example number 4. You are constructing a rectangular play area. A playground is rectangular with length 25 meters and width 15 meters. The new play area will be similar in shape but only 10 meters in length. Part A says find the scale factor of the new play area to the playground. As always, let's draw a picture first. So it says we have a playground that is rectangular with lengths of 25 meters and 15 meters. So just like that. And now we have this new play area that will be similar in shape but only 10 meters in length. So it'll look like that. So again, it says for part A, find the scale factor of the new play area to the playground. So since we only have this side and this side to correspond to each other, the scale factor would be found by taking the 25 and putting it over the 10. Since 5 is the biggest number that goes into both of those, the scale factor would be 5/2. For part B, it says find the perimeter of the playground and the play area. So that would be pretty easy. We know that for the playground, the old playground, if it is 25 up here, it'll be 25 down here. And if it's 15 over here, it'll be 15 over there. So to find the perimeter, we're just going to add up all those sides. So 25 and 25 is 50, 15 and 15 is 30, so 50 and 30 together is 80. So the perimeter of the original playground would be 80 meters. Now let's find the perimeter of the play area. Since we know from the last theorem that the perimeter would have the same scale factor as we did above, let's set up a proportion. The perimeter of the old playground is 80, and we don't know what the new perimeter is of the new play area, but we do know that the scale factor is 5/2. Since I know that the old playground is bigger, I made sure that I put the 80 on top to go across from the 5, which is bigger than the 2. So to solve this, I would just cross multiply. 5 times x is 5x, and 80 times 2 is 160. Then I would just divide both sides by 5 to get x equals 32. So x in this case is the perimeter of the new play area. So our answer is 32 meters for the new play area and 80 meters for the old. And now let's talk about how similarity and congruence are related. Any two congruent figures are also similar, and their scale factor would be 1:1. So again, it would be 1/1, which is really just 1. Let me show you why. So these two triangles, as you can see, are congruent. It's 5 over here, 5 over there, 7 and 7, 6 and 6. So again, these two triangles are congruent. If I wanted to find their scale factor between the corresponding sides, I would take one side over the other. So 5 over 5, which is equal to 1. Or 7 over 7, which again is equal to 1. Or 6 over 6, and again, you guessed it, is equal to 1. So again, if you are told that two figures are congruent, then they're also similar, and their scale factor is just simply 1. And here's a key concept when it comes to corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. So what we're talking about here is like all of those lengths that we talked about in chapter 5. So we had the altitudes of triangles, we had the medians, we had the perpendicular bisectors. All of those different special lines that we talked about in chapter 5 would apply to this key concept. If you know what the scale factor is for the similar polygons, that same scale factor would apply to any of the lengths inside of those similar polygons. So let's apply that idea in example number 5. In the diagram, triangle MNP is similar to triangle RST. Find the length of altitude NL. So again, you're already told that the two triangles are similar. So we know that we have a scale factor. So what we're going to do is set up a proportion. If you notice here, we are given the altitude here in the smaller triangle, and we're asked to find this altitude, so let's call that X. Let's pick any of the two corresponding sides. So if we see here, MN corresponds to RS. So MN equals 30, and RS is 20. So what we want to do is set that equal to X, since it comes from the bigger triangle, over 14. So we just have to set up a proportion and solve it. So we'll cross multiply. So we'll get 20x equals 30 times 14 is 420. When we divide both sides by 20, we end up with x equals 21. So the altitude of the bigger triangle would be 21. And that's it for this section. Make sure you jot down anything you don't understand so we can cover it in class before we move on, and we'll see you then.